This is the equation for a geometric series of n terms, with a common ratio greater than 1. We will decode this equation and visualize this equation with the help of a simple example and then generalize it. The initial term A is represented by a rectangular area. The next term is A times R, is just the initial rectangular area added R times. Here in the visualization we have taken R equal to 3. The next term is A times R squared, is nothing but the previous term added R times. This process continues till the nth term. For our example, let us take the third term to be the final term. Let us now look at the equation. We will split it into two parts and the series is contained in the first part alone. The second part is used to remove the residual value, as we will see shortly. In the first part of the equation, A times R to the power n is not in the series as it is the next term to the last term. Let us represent it in terms of the last term. We would notice that there is a denominator of R minus 1. Let us see why that exists. Generally, division means to divide a certain value into the number of parts specified by the denominator and obtain the value of a single portion. A similar idea is used here. We will split these into two groups, one with R minus 1 parts and the other with a single part. By applying the denominator to the first group, we get that the division will yield a value of A times R to the power 2, since it had R minus 1 equal parts, thus giving us the last term in the series. Then, the remaining part is split into R parts of the previous term. This again is made into two groups, one having R minus 1 parts and the other with a single part. And again the former reduces to a single A times R term which is a part of the series. The remaining part will undergo the same process of splitting into groups and reducing by division, but this time we arrive at the first term and the residual term. This is where the second part of the equation comes in and cancels the residual value, giving us the series sum. Hence, this equation gives us the sum of any geometric series, since the process followed is applicable to any number of terms.